So just to recap from last lecture on some of the stuff that we will be building on in this lecture, we've seen that speed is equal to distance over time, and it's a scalar, and velocity is its vector equivalent. Vector velocity is equal to the displacement over the time. Now in this lecture we're going to be including acceleration as well. Acceleration is the rate of change of velocity. So the formula for acceleration is equal to the change in velocity over the time. So the change in velocity is given by the final velocity minus the initial velocity over the time. So if an object's undergoing constant acceleration, it means that its rate of change of velocity is constant. So in other words, if we drop a ball that undergoes constant acceleration, so it starts off slowly and it gets faster and faster and faster as it falls. So let's have a look at that now. Okay, so let's watch this ball drop. And again in slow motion, you can see it moving very slowly at the beginning, and it starts moving faster and faster, and the camera starts to record it as a longer and longer blur as it's going faster and faster. So hopefully you saw that the ball started off slowly and got faster and faster as it got further down the screen. Let's do an example now of using acceleration to calculate velocities. So the question is, an object is dropped from rest close to the surface of the Earth. It falls for 2.0 seconds before hitting the ground. Calculate its final velocity. So to do this, we're going to need to use the formula acceleration is equal to the change in velocity, which is the final velocity minus the initial velocity over the time. Now, because it's close to the surface of the Earth, we know that its acceleration is given by little g, which is 9.80 meters per second per second. So we need to find this final velocity. We're told that it's dropped from rest, so because it's from rest, this means that the initial velocity is 0, and we know it falls for 2.0 seconds. So we can multiply both sides by 2. So we've got 2 times 9.80 is equal to the final velocity, and so the final velocity is equal to 19.6 meters per second. And because it's a velocity that it's asked for, we should give a direction. So this is towards the surface of the Earth.